One. Welcome everyone to a brand new week of Breaking into the Tech Industry. Pleased to welcome our special guest lecturer, Adam Yee, to talk about advanced queues and stacks. Adam, take it away.
Thank you. Yeah, so I guess like a little bit of introduction of myself first. I'm a junior here at Duke, class of 2022, studying computer science and finance. And yeah, I think that's pretty much it. Let's just get right into it then. So on the agenda, we'll talk about queues and then we'll move on to stacks. And then I think like this has been pretty consistent with the other classes, but we'll go over some problems and then finish up with final thoughts. Okay, so starting off with queues, and I'm pretty sure like stacks and queues are covered for maybe like a week or two in CS 201. And if you're taking it right now, well, I don't think they've been covered yet. So I'm just gonna like quickly review them. So queues, first in, first out, or FIFO, you might have heard that. So as you can see with the picture on the bottom, we have NQ will take an element and add it to the back of the queue, and then DQ will remove it from the front. So you can think of this kind of like a lunch line in a cafeteria, and I'm going to use this example a lot. But you know, when you're trying to get food, you show up, you go to the back of the line, and then you wait your turn. You slowly move up the line until you finally get your food, and then you leave. So one big application of queues is BFS, breadth first search. And you guys might have talked about that a little bit last week with trees, I believe. So if you're not familiar with that, that's okay, because here it is. Breadth first search is on the left and depth first search is on the right. So as you can see from BFS, what we're doing is like a level order traversal of the tree. And that's really important to remember. When you're trying to go and iterate through each level of the tree at one time, then you want to use BFS, and that's typically done through a queue. And I'm going to use an example in the next slide. Whereas DFS, you might have seen from maybe like in-order traversals or pre-order, post-order traversals. And those are pretty much done recursively, and they could be done with stacks, and we'll go over them in a couple of slides. So for example here, I just want to go through like using a queue with BFS. So say like these values here, like this might be our queue, right? So first what we do is append the root node, which is 0. And then we want to visit each one of its children, so 1 and 2. So we would dequeue 0 or take it out of the queue and append its children into the queue, so 1 and 2 in that order. And then we continue on doing the same thing. So we take 1 out of the queue, we're looking at 1. And then we append its children to the back, which are 3 and 4. So now the queue looks like 2, 3, and 4, and we've already visited 0 and 1, right? And then we do the same for node 2 here. So we're gonna take this out, append its children, which are 5 and 6, into the back of the queue. Oh, can you guys see my mouse, by the way? Okay, cool, excellent. Yeah, and then once 5 and 6 are in the queue and we visited 0, 1, and 2 already, then the queue looks like this. And then we're gonna do the same thing for these, but since 3, 4, 5, and 6 here don't have any children, nothing will be appended, and they'll eventually just all pop off the queue. So that's how we get the final order of 0, 1, 2, 3, 4, 5, 6 in terms of like the nodes that we visited. And yeah, if you guys have any questions, let me know or put it in the chat. Okay. Moving on then. So a general guideline with BFS and trees. So I'm not gonna go over a problem that involves this just because it doesn't really have to do with queues. It has to do more with like tree traversal, but you're using a queue to traverse the tree, if that makes sense. So the actual like usage of the queues is the same thing in every single case. You're just appending, as we saw here, like the root node, and then you're gonna iterate through for each node that you dequeue, you're gonna go through its children and then add that to the queue and continue on until maybe the queue is empty. So that means that you've gone through every single node in the tree. But a couple of things to keep in mind are, yeah, you're adding elements in order, in the level order to the queue. And so typically when you want to do something like that, like maybe you're going through every level and you want the sum of every like depth of a tree, then you might want to think about using a BFS. Or maybe you want like the rightmost element of a tree. And then in that case, like you could use a BFS as well and just keep track of like, okay, how many elements in each depth have I seen, right? And so the first element on the right side that you see might be what you want to keep. So yeah, another important thing to think about is determining if any extra data needs to be stored. So back to my other example with maybe if you want like the um, average of each level here, you could store it in like a hash map or a dictionary, depending on what language you use. And I guess the key of that is just, well, you know, for each level, you could add up the values of all the nodes that you visit, and then take the average of that, and then return that hash map. And finally, you have to keep in mind that these are all iterative approaches, right? So in DFS, as we've seen, and I think you guys have learned like in order, pre-order, post-order traversals like recursively, but this is an iterative approach. So make sure you don't use any recursion, and you're just adding to the queue. And typically your while loop termination condition will just be like when the queue is empty, then you terminate. And that's, yeah, when you visited every single node in the tree. Let me know if you guys have any questions at this point. If not, I'm gonna move on. Okay, cool. So here are some problems for BFS with queues. Yeah, so level or traversal, right side view, largest value in each tree. You guys can look at this on your own time. It's pretty much like the same general formula. You just want to do a BFS and then figure out what extra information you want to store and how you can return that. So aside from queues, there's also something called priority queues. And these are a little bit different from queues, and we'll go over them mostly in like a future class with greedy and sorting. But I just want to touch base on this real quick. So in a priority queue, elements maintain their sorted order after insertion. So this is really important. And I'm going to use the example of a lunch line again. So for example, right, if you have like a senior lunch line, maybe like for the first 10 minutes of lunch, seniors get to cut to the front of the lunch line and like ahead of all the juniors, sophomores, and freshmen. Well, in that case, like they would get priority, right? Which is where the name priority queue comes from. So they wouldn't be added to the end of the queue. They'd be added somewhere like in the middle or maybe towards the front of the queue. And yeah, this will be important for a variety of problems. Yeah, once again, we'll cover it in a future class. Okay, next up, moving on to stacks. Yeah, this is a first in, last out type of data structure, so phyllo. And going back to the lunch example, lunch trays on a cafeteria this time. So for example, right, if you have a stack of lunch trays and maybe like the cafeteria lady comes by and she puts on like a new like just washed tray, then that's going to be the first one that someone takes off, right? They won't like if you're going in line, you're not going to lift up the trays and take the one off the bottom out. You're going to take the top one out. So as you can see, like pushing on here, you push 2 on top, 3 on top, 4 on top, and then popping is like from 6, 5, 4, 3, 2. And then finally you end with 1. And yeah, this is typically used in DFS. So the thing is like DFS is normally taught recursively with all those other traversals, but a good exercise to do is once you've implemented something recursively, maybe try and do it iteratively too. And this is asked sometimes in interviews where they'll first like ask you to come up with that solution, and then they'll be like, okay, like now can we do it iteratively, you know? So just remember, if you're recursing through a tree, then you probably want to use a stack. All right, first problem. We're going to be looking at implementing a queue using stacks. So think about how you could implement the following operation of a queue using just stacks. So remember, queue is first in, first out, whereas stacks are first in, last out. So you probably can't just use like one stack, right? You probably need multiple stacks. Anyways, first, I want you guys to think about just pushing. So pushing element X to the back of the queue. I'll give you guys a couple of minutes. If you have any like suggestions or ideas or any questions, just like either unmute yourself or put it in the chat, and I'll go over this in a bit.
Adam, do you want to go ahead and start walking through some of these operations?
Yeah, sure. So I think one idea I saw was popping elements from one stack, pushing them onto another, and then popping them back from that second stack, which is pretty much what we want to get at here. So using two stacks is a good idea. And with push here, uh, for example, here step one, you see the top is the top of S1. Like S1 is the stack that we're trying to mimic the queue with. So we need a helper stack S2 for push operations. So for example, like we're starting out with step one. First, we pushed all of the elements from stack one onto stack two. And so now we have them flipped in that order. And then what we can do is just push an element three onto stack one and then push the elements back from stack two to stack one. And then we'll finish up with this order, have one, two, and three, where one is the top and then three is the bottom. So can anyone tell me the runtime complexity of this algorithm?
It would be O of n, where n is the size of the stack.
Yeah, exactly. Because we're popping n elements onto stack two, and then we have to pop n elements back onto stack one. Yeah, perfect. If no one has any questions, I'll move on to push next, or sorry, to pop next. Here's the code for push, by the way. It's in Java. So pop, does anyone have any ideas of how we can just do that?
Wouldn't it just be the same since the way
Yep.
you took care of the push is, yeah.
Yep, exactly. Since the top of the stack will be also like the front of the queue, right? We can just pop that one off and get it. Yep. So there's the code for pop. And then peek is pretty simple. Also, we're just like returning the first element of the stack. And empty is also pretty simple. We're just returning if S1 is empty. Okay, anyone have any questions on this example before I move on to the next problem? Okay. All right. Cool. Moving on to a slightly harder problem now. Basic calculator 2. So implement a basic calculator to evaluate a simple expression string. And the expression string only contains non-negative integers, plus, minus, divided by, and multiplication operators and empty spaces. So also the integer division should truncate towards 0. That means that you want to round down. So going through a couple examples here, maybe your input is 3 minus 2 times 2. And in this case, you want to do 3 minus 2 times 2, which is 4, and that gives you -1. And then here, 3 plus 5 divided by 2. Well, 5 divided by 2 is 2.5. But once again, we're rounding down, right? So it would be 2, and then adding 3 is 5. So yeah, I'll give you guys a couple more minutes. Think about, like, first of all, like, what data structure do you guys think that we should use in this case?
I'm gonna guess a stack.
Yeah. Yeah, exactly. Yeah, so I guess one idea here, I'm gonna go through this really quickly, is like maybe you could traverse the string and store the current number. And then when you see like an operation, for example, like one of these, you can perform it. So going back to our example here, if you like see like 3 minus 2, then you just like do that and you get 1, and then you continue on through the end of the string. But anyways, does like, so this would probably be like using a queue maybe, but do you know like why this wouldn't work?
Order of operations.
Yeah, exactly. PEMDAS. So yeah, I'll give you guys a couple more minutes to think of like maybe another way. You guys can unmute yourself or just like message the chat.
Adam, in just about a minute, do you want to, as an example, walk us through what your thought process would be if you got this question in an interview?
Oh, sure. Yeah. So once again, first of all, I would be thinking of like maybe what kind of a data structure I could use to help me because if we just traverse it like we just talked about, right, we would run into issues with the order of operation. So maybe we want to account for how we can, you know, do the operations in the correct order and still maintain like the correct result in like a given data structure. So first, like think of the data structure, and then think of like how you can use the data structure, and maybe like keep all the information we need, and then return it. And I'll give you guys a hint real quick. So normally with stacks, um, sometimes you'll want to do operations on whatever elements are inside of the stack until maybe you only have like one element left in the stack and then return that one. That's a pretty popular approach, but sometimes also you want to maybe keep like multiple elements in the stack and then maybe return like a sum or like an average of those elements at the end. Um, so just keep that in mind. Oops. Okay. I guess I'll give like another hint. So earlier when I was talking about like maybe saving multiple elements in the stack and returning something else, think about how you can do this with saving elements and returning like the sum of those elements at the end.
So just to give some time on the clock, let's wait until about 8:25, which is going to be about 1 minute, and then go through what a solution might look like.
Okay, I sort of have an idea, um, which is like, so you have your stack and which has like all the characters in it.
Mm-hmm.
So at the bottom of the stack would be like the beginning of the input, and the top of the stack would be the end of it.
Sure.
And I think you'd want to like keep popping from it until like the thing at the top is either a plus or minus or it's just empty. Like at least that would take care of like doing division or multiplication first.
Okay.
I think that's a
Um,
starting point.
okay. So you're saying like maybe push every single thing onto the stack to begin with.
Yeah.
Okay. So yeah, that's a good idea. However, in this example, right, if we're pushing 3 and then -2 or 3 and then a minus sign, a 2 times and a 2, that could work because then it'll do the 2 times 2 first. However, think about maybe if we had like like another addition at the end here, like maybe 3 minus 2 times 2 and then plus 3, right?
Oh yeah.
And then in that case, it would do the 2 minus 3 first.
So I guess like you'd want to look for, I don't know, maybe look for multiplication division first, and then do that. I don't know.
Mhm. Sure. I'll go over most of like what you want to do. So the big idea here is that minuses and pluses. So like I said earlier, right, you might not want to just store like one item onto the stack. You might want to store a bunch and take the sum of them at the end. So what you can do is when you see like a number, you want to append that to the stack. And then when you see a minus sign, you can append the negative of the next number onto the stack too. So hold on here. Add numbers to the stack plus or minus, and then you want to perform the operation only when there's a dividing operator or a multiplication one. And then at the end, you want to return the sum of the stack. So I'll walk through this example input here too. So first of all, like say this is the stack right here, you have 3. We push that, and then next up we encounter the minus sign and then the 2 at the end there. So we want to append -2 onto the stack. And then we see multiplication, right? And so we're looking at the next number after that as well. And then we pop off the first element of the stack and we multiply that together. So now we have 3 and -4, and that's how we get our sum of 1. So we end our stack, like we end adding to the stack when we get to the end of the string, if that makes sense.
There's a question from the chat from Justin, who asks, do we have to account for parentheses as well?
Yeah, in this case, no, we do not have to account for parentheses. There's another problem. I think it's basic calculator 3. In that case, you might have to account for parentheses and a whole lot of other operations. I'll like add it to the slide and give you guys a link. Okay, does anyone have any questions about this approach? Like, is this clear? Okay, I'm gonna assume that means that everyone's okay with it. So then moving on, here is the code for basic calculator 2.
Do you want to walk us through how this relates to the pseudocode that you just walked through?
Yeah,
the logic
sure.
you just walked through?
So first of all, like, well, another thing we had to account for was that we had to get rid of empty spaces. So this code kind of just like does that if you see anything that might not be exactly the same logic as what we talked about. But in any event, so here's the for loop that it starts looping through the string. And as we can see here, if the character is a digit, then we want to get the number here. This is basically like converting the string to an integer. Yeah. And then next up, if it's not a digit, then we want to push that number. And if it's like a minus or plus, then we want to push the number that we got over here, right? We want to push that onto the stack. And then if it is a multiplication sign or a division sign, then we want to essentially pop the first element off the stack and then multiply that by the number. So here we're looking at things in pairs essentially. So remember going back to this example, right? As you can see, like in the bold on the top, like the first thing, obviously we're gonna have a number, so that's just 3. And then we want to look at minus and 2 coupled together. And then we want to look at times and 2 also coupled together. And that's really like the key of this, is that when you look at that and you append only if it's a plus or minus sign, and if it's like a multiplication or division, then that's when you pop. And then that'll give you the right sum. And then I think the rest of it, probably like the beginning and the end here, is just a little bit of Java to clean it up and then return the right result. But the main bit of the logic here that you should understand is within this for loop. All right, I'll give you guys like another couple seconds. If you guys have any questions, feel free to ask. Otherwise, I'll like wrap it up with some closing thoughts. Thank you, Kevin. Sure, then num times num, oh, num plus num times 10. If character is a, okay, so if the character we see is a digit here, then yeah, I think here, so num here, we begin it as 0. And for example, like with the first one, maybe we have an input of 3. So if the string is 3, then this right here, s.char at would return at I would return 3 as like a character. And then we want to let me think about this. And then this will convert the 3 into a number 3 just by like the way of this addition here. And that's really like what the number is. Like this line is really just converting whatever number is in the string into an actual integer, from like string to integer, right? And it's just a bit of Java. In other languages, it might just be like num equals str and then parentheses like whatever the character is at that index.
Yeah, and I think the num times 10 is like for taking care of double-digit numbers, right?
Yeah, exactly.
Okay,
Yeah,
okay.
you can probably just use integer dot parseInt. That would work fine too. Right. What if the string s is invalid? That's a good question. In this case, we can assume that, I don't know if I put it here. Oh, I didn't, but yeah. In this exact problem, you can assume that it is valid. Otherwise, you would probably have to have like a lot more different checks. And honestly, that doesn't take away from the main logic of this, which is once again this for loop here, but it just adds like a bunch of more base cases that you just need to check over. All right. If we're all good with this, then I just want to go over like a couple main points once again. So the key with queues and stacks is that queues actually, like, typically you won't see them in their own problem. Stacks on the other hand, you might see, like, for example, with this basic calculator thing, or another one that's really popular is like valid parentheses, where you have a string and you have opening and closing parentheses, and you want to like make sure that you know you have one opening matching to one closing, and the expression is valid. And I could put that problem at the end of the slide too for you guys. But queues, really, like, you're gonna use them during a BFS, right? So as we saw with the level order traversals, and you're just gonna have to like implement it. You won't actually have to, like, you know, do some like tricky queue manipulation, I don't think. And also keep in mind that there are priority queues, which you guys will once again cover in a future lesson. But yeah, that's pretty much it with stacks and queues. Let me know if you guys have any questions. You can just put them in the chat. And yeah, I'll stick around for a little bit longer.
Adam, just as a final note, do you want to share to the people in this class what tips you found most helpful for preparing for interviews and for tackling questions that you don't know how to immediately solve?
Sure. Okay. First of all, Kevin just asked how are stacks and queues implemented. Well, another good question is to implement a stack with queues. Yeah, you can implement it with different data structures. Honestly, like you could use an array to implement it, or you could use like linked lists. And typically, like, yeah, if the interviewer asks that, then you just have to keep in mind, like, you know, what kind of properties a queue and a stack has, which are the first in, first out, and first in, last out, respectively. And yeah, just keep that in mind when you're going through the problem. But like typically, like any data structure you can use to implement them. So yeah, in terms of like advice for interviewing, I think that If you have like a problem that you haven't seen before, it's okay to like take a little bit of time and first like ask clarifying questions of the problem and make sure you fully understand it first, right? And make sure maybe like you want to run through some example test cases with your interviewer, or maybe like go through certain, I don't know, certain questions, whatever you may have, just fully understanding it first, and then thinking about, you know, what have you learned that might possibly apply. Um, so if it's like a tree problem, and maybe you want to find like I don't know, one of these problems right here. Yeah, one of these problems, like minimum depth of the binary tree, you might want to think like how you can, so it's a tree, right? So you might think, okay, maybe I could do a DFS, maybe I could do like a BFS, um, and hopefully like one of those two would return the right answer. And then you could like build from there, maybe like, oh, you know, like I know with a BFS, well, it would do like a level order traversal. So maybe like the first node that doesn't have a child might be like the minimum depth. If that makes sense. So you just kind of like build yourself up from there, starting with like what you already know and what you've worked with, and yeah, just create, you know, like map a couple of things of what you know to like what you might find applicable in the problem. More comments in the chat. What's a tree? Who's a tree? So we went over trees in the last lecture, and trees are basically linked lists with different pointers. Yeah, you're fine.
You may also want to answer how do you go about preparing for interviews?
Sure. How do you go? Yeah, that's a good. That's a good question.
What's your strategy?
Yeah, for sure. So what I tend to do is, you know, some of the most common problems can be like grouped into different categories. Maybe like stacks and queues, there's one category, and then trees could be like another category, and then you could have like arrays as another one. So typically what I want to do is like go through LeetCode and do problems in those categories until I'm familiar with them, right? And once again, like the more you do these problems, like the more you'll start to realize, okay, when you see a problem that you haven't seen before, maybe like, oh, like I've done something similar in the past, and so maybe I can draw on that knowledge and then apply it here. And really it's just like a lot of practice. You have to go through LeetCode, you have to like do the problems and actually implement them yourself, and not like be tempted to go to the solution first of all. And just try to write it out yourself first. So yeah, I think practice is good.
Do you think it's worth doing mock interviews where you like talk about it out loud?
Oh, for sure. Yeah, that's also a good point I forgot to mention. Mock interviews are good because when you're doing LeetCode by yourself, like maybe you'll probably be able to understand the algorithms and you'll be able to implement them really well. But another key part about technical interviews is actually, you know, being able to talk out what you're doing and verbalize your algorithm and verbalize like your thought process, right? So mock interviews are definitely a really good way to do that and practice. So I would recommend, you know, you don't have to go too crazy on those, because really like you should be focused more on the algorithms, and mocking, like speaking them out, like I feel doesn't take too much extra effort once you have the algorithm down. But definitely go through maybe like once or twice before like an interview. Any other questions? Like you can ask anything about CS, about interviews, about SWEs, about life. I am good, Michelle. Thank you for asking. How do you interview? Yeah, you come to all the breaking to the tech industry classes, and you'll eventually learn and ace all your interviews. I'm not sure where I'm working this summer. I'll keep you updated, Kevin.
All right. That sounds like a good place to wrap it up. Thanks again, Adam, for all your help and for teaching stacks and queues.
No problem.
Seriously, huge round of applause. All right, I'm gonna go ahead and
Thanks.
stop the recording.